CompTIA Cloud Plus, Containerization Concepts in Cloud Architecture. I'm sure by now you know what a container is, but let's just remind ourselves that cloud containerization refers to a lightweight form of virtualization that packages applications and their dependencies into isolated units called containers. For example, Docker. These containers historically share the host system's operating system kernel, but run independently, making them highly portable and efficient for cloud environments. Remember, we can run containers today without servers or serverless, for example, AWS Fargate. Some key containerization concepts would be standalone containers. These are self-contained environments for running applications. Workload orchestration. Tools like Kubernetes or K8 that manage container deployment, scaling, and networking. For example, using an elastic container service at AWS, Google Cloud, or Azure. And container networking, including port mapping and virtual networks. In this particular lesson, for the CompTIA Cloud Plus exam, we're going to explore deeper two other containerization concepts, starting with storage types, such as persistent volumes, where data survives container restarts, and ephemeral storage, or temporary data, and image registries, repositories for storing and retrieving container images. On the exam, you want to be able to compare persistent versus ephemeral storage. There's 7 features to be aware of. First, data retention. Persistent storage survives container or pod restarts and rescheduling, whereas ephemeral storage is lost when the container or the pod is terminated. Use cases for persistent storage would be databases, logs, user uploads, and stateful apps, whereas ephemeral storage is used for caching, temporary files, scratch space, and session data. As far as lifecycle goes, persistent storage is decoupled from container lifecycle, whereas ephemeral storage is tied directly to the container or the pod lifecycle. With provisioning, persistent storage is done via persistent volumes, PVs, and persistent volume claims, PVCs. Ephemeral is often provisioned using commands like empty-dir, config map, or secret volumes. For performance, persistent storage usually varies depending upon the back end. For example, is it network attached? Modern CSPs have 100 gigabit per second networks, but some newer ones, for example, AWS Northern Virginia region and the Oregon region, actually have up to 400 gigabit per second. But ephemeral storage is typically faster due to local node storage. In other words, it's directly attached to the cluster or the same leaf switch in the VXLAN data center. As far as accessibility goes, persistent storage can be shared across pods and nodes, but ephemeral storage is usually local and not shareable. And then CSP integration. Persistent storage is backed by services like AWS Elastic Block Store EBS, Azure Disk, and GCP Persistent Disk. Ephemeral storage is backed by local solid-state drives, in fact massive arrays, or boot disk partitions. Make sure you know these differences for the Cloud Plus exam. And then we have image registries. At a CSP, image registries are essential components in the containerization workflow. They act as centralized repositories for storing, managing, and distributing container images. They're basically the blueprints for running containerized applications. An example would be Amazon Web Services Elastic Container Registry, or ECR, which could then be orchestrated with EKS, Elastic Kubernetes Service. Let's talk about some of the use cases for image registries, starting with storage and versioning. Image registries store container images in a structured format, often organized by repositories and tagged versions. This way, developers can maintain multiple versions of the application. They can roll back or fall back to previous versions if necessary, and they can track changes and updates over time. A second use case is deployment integration. CSPs like AWS, Azure, and Google Cloud offer native registries. And as I've mentioned, there's Amazon ECR, the container registry. There's Google Artifact Registry that integrate tightly with their orchestration services. Also, as far as deployment goes, you can perform seamless image pulls during container deployment. You can automate scaling and updates using the latest image versions, and you get secure access control via identity and access management roles or service principals. Third is security and compliance. Registries often include features like image scanning for vulnerabilities, access control policies for least privilege principals to see who can push or pull images, and audit logs for tracking usage and changes. Image registries are a key part of the DevOps workflow. After a build completes in a CI pipeline, the resulting image is pushed to a registry, and from there it can be automatically deployed to staging or production, or pulled by other services or environments for further testing. And then finally, there's geo-replication and caching. To reduce latency and improve availability, CSPs often support geo-replication of registries. This ensures that images are available close to the compute resources that need them at all times. I hope this lesson's been informative for you. We'll see you in another video. Thanks for watching.